Okay, guys, so now what I'm going to do is some of the identity problems. I don't know if I'm going to do all of them because the odd ones are different than the even. There's a reason why I picked the even ones, but some of them I can do. So your homework is 2230 even. I'm going to do odd. So let's start with 23. So 23 is the cosecant x minus cosecant, yes, x minus cosine x times the cotangent of x. Okay, so if you remember, the first thing I told you to do is write in terms of sine and cosine. So cosecant is really 1 over sine x minus cosine x times, I'm going to rewrite cotangent as cosine over sine. Now, I can multiply these together, okay? They don't need a common denominator, and I'm going to get 1 over sine x, I'm just recopying the first fraction, minus cosine times cosine is cosine squared x over sine x. Now, when my denominators are the same, I can combine my numerator. So, 1 minus cosine squared x over sine x. Okay, guys, this has got to start coming to you naturally, and I know it's not going to because you just learned it, but see something like this? Bells should be going off in your head. Ding, 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 because 1 minus cosine squared x is really sine squared x. So I could replace this as sine squared x over sine x. This would cancel with one of those, and my final answer, I could simplify that whole expression down to just the sine of x. All right, I know some people see these right away and they love them. Some people, you have to work at them. All right, it's like a puzzle. Let's see if 25 is pretty ugly looking, but I always find that the ugly looking ones that I look at, I'm like, holy shoot, how am I going to do that? They kind of work out to be pretty simple. Let's see if that's true. Cosecant x tan x. Okay, so I'm going to change into sine and cosine. I'm going to start with the numerator. So tangent is sine x over cosine x, plus this is sine x times secant is 1 over cosine x, which right off the bat, look, this is just going to be, I'm just going to continue with the numerator for a second. This is sine x over cosine x, plus when I put these two together, I just get sine x plus cosine x, which means now when you add fractions, you don't add the denominators, just add the numerator. I have 2 sine x over cosine x. So that's what I just got this whole numerator to simplify out. Let me try the denominator and see what I get going on. It's cosecant is really 1 over sine x times tangent is sine x over cosine x, right? Sines are going to cancel out. So this whole thing is over 1 over cosine x. Now, remember what we said in the previous problems about the denominators when they're the same? I mean, you're technically saying this divided by this, which means you're reciprocaling this and multiplying it. These cancel out, so I'm just left with 2 sine x. So one that looked like it was going to be a little more challenging, really wasn't that bad. Okay, trust me, that is not bad. Let's look at 27. By the way, this is what we're going to be doing for most of the chapters, so you really need to learn how to do these. Okay, so let's look. 27 is cosecant x cosine x plus cotan x over secant x cotangent x. Okay, it's probably going to work out to be the same as something like that. So let's see. The numerator is 1 over sine times cosine plus cotangent is cosine. Yeah, it looks like it's working out to be the same as the previous, right? This is going to be now cosine over sine plus cosine over sine. So that gives me 2 cosines. Now remember, that's not cosine squared. You're not multiplying, you're adding it over sine. So there's my numerator. Let's do the denominator. Secant is 1 over cosine. Cotangent is cosine over sine. Same thing's happening here. This is going to cancel out. 1 times 1 is 1 over sine. That's the same problem, only flipped. So we have 2 cosine x. All right, let's try doing, how much time is this? Oh, only 6 minutes. So let's look at 29, because 29 is similar to what you have to do is 26. So 29 says secant squared x over cotangent squared x plus 1. Okay, ladies and gentlemen, I hope you watch this video before you do your homework, because I did tell you to change everything in terms of sine or cosine. All right, however, I notice that I have an identity here. Cotangent squared theta plus 1 is cosecant squared theta. So this really is secant squared x over cosecant squared x. Okay, so what does that mean? Well, I think it was actually in the identity paper that I gave you that this became tan squared x, but you might not see that right away. So let's just work this one out. Secant is really 1 over cosine squared x divided by cosecant is 1 over sine squared x. Let's do the math, guys. This 1 over cosine squared x divided by this is really this times the reciprocal, which gives me sine squared x over cosine squared x, which really is, I'm running out of paper, tan squared x. Okay, so that's what that simplifies to. Okay, you know what? I'll finish it up with number 31. That was 29. 31 cotangent x minus cosine cubed x cosecant x. Okay. I thought maybe I could factor something out, but I can't the way it's written, so I'm going to change it. I'm going to change cotangent to cosine over sine minus cosecant cubed x times 1 over, this is sine x. I can multiply this and I'm left with cosine x over sine x minus cosine cubed x over sine x. Now I have the same denominator, so I'm going to put those together in my numerator. Cosine x minus cosine cubed x over sine x. Now I could factor out a cosine. So this numerator, if I take a cosine out of both of them, I'm left with, if I take a cosine out of here, I'm left with 1 minus cosine squared x over sine x. At this point, I hope bells are going off in your head, ding, 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 because this is one of my Pythagorean identities, okay? 1 minus cosine squared is sine squared. So it's going to be cosine x times sine squared x over sine x, and then this could cancel for one of these. So my final answer is cosine x sine x. Okay, I hope me doing the even odd problems help you guys doing your homework problems. Okay, don't give up on it. Keep going back and trying it. I'll see you in class.